matrices. If you took high school algebra, you probably remember them as these tedious little boxes of numbers.
Row times column. Add the products.
It feels like accounting. It feels like homework. But what if I told you that these numbers aren't data? They are instructions. They are the controls for a machine that warps the very fabric of space.
Welcome to the hidden geometry of the matrix.
To understand it, we need to stop looking at the numbers and start looking at the space they live in. Let's place two special arrows at the center of our world. We call them basis vectors. This red one pointing right, that's I hat. And the orange one pointing up, that's J hat. They define what right and up mean in this universe. Every other point in space is just a recipe using these two ingredients.
3 steps right, 2 steps up.
Now, here is the magic trick. A matrix is not a static grid. It is a transformation. It tells I hat and J hat where to move. Look at the first column, 2, 1. That is not just a list. That is the new destination for our red arrow, I hat. And the second column, -1, 1. That is the new home for our orange arrow, J hat. See that? The entire grid warped. Parallel lines stayed parallel, the origin stayed fixed, but space itself skewed. This is what a matrix actually is. It's a function that takes our nice square grid and squishes it into a new shape. Let's play with the knobs. If we change the numbers, we change the warp. Watch. If I scale the numbers up, space expands. If I use negative numbers, space flips inside out. This is why linear algebra is the backbone of modern AI. Think about a neural network. We often draw them as these webs of circles, but that hides the truth. A neural network layer is actually a geometric operator. Its job is to take messy, tangled data and warp space to untangle it. Imagine these red and blue dots are different types of images, maybe cats and dogs. Right now, they are mixed up. We apply a matrix. Let's try a shear transformation. Look at that. By stretching space, the groups are pulled apart. This is what learning means. The computer is just searching for the specific matrix, the specific warp, that makes the data easy to slice. When you hear about parameters in a model like GPT-4, those are just the coordinates of these basis vectors in millions of dimensions. It's the same principle, just a lot harder to visualize. So next time you see a matrix, don't see a spreadsheet. See the arrows, see the warp, see the architecture of intelligence.